When it comes to the test, every equation you will need for a story problem you will be given. So I'm not expecting you to memorize any equations for your story problems. I don't feel that any of these equations are necessary enough. Not to mention, this book gets a little, I don't know, confusing with its terminology because they give you multiple equations for exponential growth. They don't differ in their labeling of them. Because for exponential growth, they give you this one, plus earlier we had another equation for exponential growth. There is a difference between the two equations, but they don't go into that, and again, they labeled them exactly the same. So in this unit, we're using this equation, or this section, we're using this equation for exponential growth. The radio's still on. This section is also more of the multi-step problems instead of the single step. So before you've had some story problems and all of them have just been plugging numbers in and you automatically get the answer. These are going to be more of, well, okay, some of these are still going to be plug in the numbers, get the answer. But some of these are going to be multi-step. So I'm going to do one example where we have a multi-step, and then besides that, again, with story problems, I could go through 10 story problems and still not give you an example of all the different types of story problems. So with these, I'm just going to give you kind of a random sampling of them in your homework, go through them, and then as you have questions, I'll help you with them. Okay, so we'll go over this type because it doesn't matter what I do. We always have issues with this one, so I just figure I'll do this one in notes this time. So what this is half-life of an element. For half-life of an element, what you're going to use is you're going to use exponential decay. Because what this does is this element exponentially decays. Part of the problem is they don't tell you that in the problem. So this is what we're using. The only change in it is x is actually, normally we consider that to be t, because it's going to be time. This is our final amount. This is our initial amount. And t is time. What that leaves is B kind of undefined in a lot of these equations. B most of the time is some constant that they're going to give you. Now, in these half-life formulas, they don't give you B because B is different for every type of element. So normally what you do is this is a two-step equation. You have to start off by figuring out what B is. I'm trying to remember what that's called. It actually has a name, but I don't remember what the name is. So our first step is we have to figure out what B is before we can solve our problem. We have to figure out what B is for the element Ra. I think it's radium, but I don't know that. I was good at chemistry, but not excellent at chemistry. And it's been a while. Okay, so to start this problem off, to find B, I know that the half-life of this element is 1,599 years. What that means is, however much I start off with, in 1,599 years, I have half of that amount left. That's the definition of half-life. Now, if I divide both sides of the equation by A, the A will disappear. So I can solve for B. Okay, so this is an equation like yesterday. I need to find the variable up here. How do I get rid of the exponential? By using log. So what I'm going to do, to get rid of an E, I'm going to use ln. I don't want that up there. I want it in front of it. So I'm going to ln both sides. Sorry, I always forget to get out my calculator. And I forgot my negative sign here. Okay, so there's B. Okay, so that's the first step. I haven't even got to the actual problem. I needed to find B before I can even do my actual problem. So my actual problem says, if there's 1.5 grams left after 1,000 years, how much was there initially? So I come back to my original equation. So 1.5 grams would be which variable? That would be y. Left after 1,000 years. 1,000 years would be what? That'd be time. And then how much was there initially? So I'm looking for what? A. So I plug all that into my equation. So I have 1.5 equals A times e to the negative 0.00043 times 1,000. So what I'm going to do is I'm going to divide both sides by whatever that is. So A is going to equal 1.5 divided by e to the negative, let's see, that just means I move it over 4 places. Yes, 0.43. Or sorry, 3 places, not 4. So 1.5 divided by e to the negative 0.43. So A is 2.3 grams. Okay, you're good with how I did all that? Now that was one of your hardest problems. That's why I chose one of those to do. Again, some of your problems are as easy as just plugging in numbers again. All right. Oops, that's odd. It's not as bad as it looks. Most of the groups are only like 3 problems. Maybe 4 problems. Yeah. Well, not much. That's all the farther I'll scoot up.